Hey guys, I'm going to do a quick review video on Pythagorean theorem with you. If you are looking at your practice document right now, this is what I'm going to be using. So if you don't have this ready to go ahead and get that out now. I'm going to go over the basics again. So if you were not here yesterday on Monday, this will be a great review for you if you need to hear it all again before you go practice. I'm going to go over the basics, and I'm going to do one or two different types with you really quick, okay? So the main thing to understand about Pythagorean theorem, because the formula is on your reference sheet, right? You don't have to memorize that. It is on that reference sheet right there for you, and we're going to go over that in a second. The biggest thing that we need to remember for Pythagorean theorem is that when we get a number squared, the opposite of something squared is the square root. It is not division, okay? It is getting the square root. So let's go over that. Let's go over all of it right now. So we learned yesterday that Pythagorean theorem only works in right triangles. So if you need to pause and write that note right there, you can. We talked about that yesterday. And the two sides or legs that make up the right triangle are called side A and side B. And then we have our hypotenuse here, which is always the side across from the right angle as C. So even if you spin that triangle around, there's still always going to be a slanted side or the side that's across from the right triangle, and that is your hypotenuse. So in this case, I would be calling my legs A and B, and then I would be calling my hypotenuse my side C. Okay? All right, and then of course our full formula is whatever the side A squared plus side B squared is going to equal the side C squared, okay? And then like we said a second ago, and I told you to write up here, but this only works for right triangles, so triangles that have that right angle in. So what's going to happen most of the times is I'm going to either have where A or B is missing or where C is missing, and then we're going to have to plug in those numbers and find that side, okay? So if you need to take those notes, take a quick pause and keep going. I'm going to do this one next, and I'm also going to take a second and grab a calculator, and you should do the same. All right, and now, just like we always do, we're going to write our formula first. So we're going to say A squared plus B squared equals C squared, all right? And now I'm going to go look at my triangle. I'm going to note where the right triangle is because that's going to help me kind of identify what sides are what. I'm going to call my two legs A and B and my hypotenuse C. And no, it does not matter if this one's A or this one's B, but it does matter that this one's C. That is the only one that's across from the right angle, okay? In this case, I'm going to call that one A, which means I'm going to be solving for A. So I'm going to fill in right here that I don't know what A is. So I'm going to be solving for that A squared. I do know what B is. B is 16 squared. And then C squared, this C has a value of 20, so 20 squared. So this next step, you cannot keep these as the values they are. You have to actually square them to get those values, okay? And we spent last week focusing on those squares and square roots so that we could do this part right here. So in my next step, I'm still solving for A squared, but I'm going to break down now what 16 squared is. And you can do 16 times 16, or you can simply do 16 squared and get 256. And then we can also get 20 squared here, which is 400. So I now have technically a two-step equation, okay? But we got to remember that that squaring, though, is not like a normal coefficient. When we get rid of squaring of the squares, we're going to have to do the square root, all right? So we're going to bring this over, though, in normal equation fashion as doing the opposite of plus 256, which is minus 256. Right here, and we will cancel this out, and we would be left with A squared equals 400 minus 256, which is 144. Now, we talked about this yesterday, and hopefully you start getting in the rhythm that you're going to memorize these perfect squares. But this is the step that we always see students make mistakes on. I'm down to the equation A squared equals 144. You cannot divide like you normally would in this step. To get A alone, to get what the length of this missing side is, I need to figure out, well, what number times itself gets me 144? And hopefully you already have it in your head. But to actually solve that, we would say, well, the opposite of squaring is to square root this number. So now we would say that A is going to equal the square root of whatever 144 is. And if you don't know it offhand, remember then your calculator, clear, you're going to press second and you're going to press square root 144 and close those parentheses, and you're going to get a value of 12. So now I found my missing side of 12. There wasn't a unit on this one. I'm going to go fill in right here as 12. And I also like to go, and I told my students this yesterday, I always like to put my measurement right there that I can see all three measurements of the triangle. And I have all my math very clearly labeled, okay? So if you need to pause and catch up to write this one, then go ahead and do that now. I'm going to do one of this bottom part right here, and then you're going to go through and work the rest of this packet, and a key will post at the end. All right, so I like questions like this right here because this is not necessarily giving you a triangle. This is asking, is it a right triangle? So what I'm going to do is if it gives me an A, B, and C, I'm going to plug in and just see if it checks out, if it equals each other. So this should look like, we know our formula is A squared plus B squared equals C squared, okay? I'm going to go simply plug in what my A, they want to say 6, so I'm going to say 6 squared, plus my B, they're saying 8 squared, and then they're saying that would equal 10 squared. So if this checks out to be true, the value of this squared plus the value of this squared equals the value of this squared, then that triangle is a right triangle. There's no other, like, we don't need a picture to see that. It checks out to be true. So I'm going to go do my squaring and check that math there. I know that 6 squared is 6 times 6, which is 36. Okay, and just a refresher here, you remember you can press this. If you don't press the second button on that exponent calculator right there, it will square it for you. Okay, just a little trick. So 8 squared is 64. And remember that if sometimes helping out writing it by multiplication steps underneath is a great idea. And of course, 10 times 10 is 100. So if this is a true statement, the answer is yes, this is a right triangle. And I'm going to go check that 36 plus 64 does equal 100. So 100 does equal 100. I don't need to draw this triangle out. Yes, this is a right triangle. So now when you do that second one, if you get anything but the same concept, if you get anything that doesn't equal each other, then it could be a triangle, but it might not be a right triangle, okay? So here's your review on Pythagorean. Biggest reminder, and you can make this little note wherever you want, and we made this note a lot yesterday. The biggest hint for you to understand is you have to understand that a number squared is times itself, right? But if we are getting the backwards of that, if we end up with a B squared, we can't divide, we have to get the opposite of that. And we would say that the square root of that number is asking what number times itself gets me that number. Well, 144 is a perfect square, so the value is 12. Okay? All right, and that's your Pythagorean theorem review. You're going to go try the rest of this. So these right here, this, and the next page. And lastly, I gave you a spot for your IXL at the bottom. A key will post for this at the end of each block, and I hope you have a great day.